Hey guys, this will be the weird way that I'm going to communicate with you. Unfortunately, you do still have to see me, but and hear from me. But hopefully, by providing these short little video clips, you can still learn what you need to do to finish our class this semester. So before spring break, we talked about two sample tests, and we looked at how to find the observed difference, the expected difference, and then we also talked about the SSE difference. So I'm going to share with you an example that is reviewing the two sample tests. So we are actually going to look at ACT scores from San Juan High for the last 3 years. So this includes your class plus the two classes before yours. So what I did is I put all of the data in a link in announcements. Obviously the names aren't attached, it's anonymous. Anyway, so you're going to use this data, and this is where I got all of my numbers from. Okay, so this example that I'm going to go through with you is just like the quiz that I'm going to have you take. And don't worry, I am going to let you take it twice after I provide you feedback after the first attempt. So, well, if you need to take it twice. So what I did is I got 30 random numbers for females and 30 random numbers for males, because we are going to look at, well, is there a difference between male and female ACT scores at San Juan High for the past 3 years? Or is there not a difference? Are they pretty close to being the same? So before we get to the null and alternative hypothesis, I got my 30 random numbers, okay, which you will be provided on the quiz, but then you will just have to get your data from those random numbers. So what I did, as you can see here, I got the first female was number 59. So then I look on my sheet for female 59. And for this example, I was looking at the composite ACT score. On your quiz, you will actually be looking at the math, which is the highlighted one, is the math score. But for now, I was just looking at, okay, here's female 59, and she got a composite score of 20. So that's why, oh geez, hold on. So I remember what I did here. So why it doesn't match with random female 59 is because I used different random numbers like that I didn't have on this sheet. But anyway, so I had different 30 random numbers, but it wouldn't matter. My first random number had a composite score of 29. And then my next one had 22, and so on. So I'm going to put those 30 random numbers in a list, the 30 for female and 30 for male. And yes, it will take you a little bit of time to look up your random number and what that person got on the ACT, but it's okay. It's not too long and you won't die. So anyway, so after that, you're going to find the average and the SD. So remember, let me go back to my calculator. So remember, I'm going to go menu 411. And I actually have two lists, so I'm going to change this to 2 and hit OK. And then I just select my 2 lists. I'm going to do females first, since they're listed first on the assignment. So females, then males. And then as you can see, my window's in the way. All right, so as you can see here, from my sample of 30, the average composite ACT score for females was 19.23, and the average composite for males was the 18.5. So I'm going to put those down. So 19.23 and then 18.5. And then the SD is right here. So we have the SD for females is 5.28, I guess. We'll round to the hundredths place. And what was males? 4.5. Okay, so now I have that information, which will help me do everything else. And it's important to know that choosing the random numbers and actually finding it takes a little bit of time, but it's really smart to know how a truly random sample is done and how it's done properly. So anyway, so the null hypothesis. Now, remember, the null is always it equals something, and the alternative is where it's either greater than or less than or not equal to. So the null hypothesis here is going to be the average composite. I'm going to abbreviate just to save some time. Average composite ACT scores with females. Oh my goodness, this is bad writing. Sorry. Females and males at SJH. You could say is the same, okay? Or I could have started off the sentence with there is no difference between the average composite ACT scores with females and males at SJH. So either one would work. And then the alternative, now we don't know if females score higher than males or males score higher than females. We are just testing, well, is there a difference? So does one score higher than the other? So then we're going to say there is a difference between, difference with average composite. I'm sorry for abbreviating all this. There is a difference with average composite ACT scores between females and males. SJH. Okay. So the null is there is no difference, and the alternative is there is a difference. So is this a one-sided test where we're finding only the area on one end of the normal curve? Or is it a two-sided test where we're finding the areas in both ends of the curve? And hopefully your answer to that is a two-sided, because we're saying there is a difference. So which means which is the same as they're not equal to, or they're not the same, right? So the observed difference, I am just going to go female minus male since females was listed first. So average female score, composite score, is 19.23 minus, what was it, 18.5? 0.5. So the observed difference, 0.77 maybe. I gotta double check that, because that'd be embarrassing if I did my mental math wrong. 18.5, 0.73. Yeah, close. Okay, so 0.73. Wait, did I even type that in right? Oh, you guys, you think I make mistakes live in class? I make even more recording myself. Okay, so that's the observed difference in the ACT score. The expected difference, which comes directly from the null hypothesis, is there is no difference. So we expect the difference to be 0. All right, so SE for females, how do we find the standard error? So we are going to take the standard deviation for females, which is 5.28, and we are going to divide it by the square root of our sample size, or the square root of the number of draws from the box model. And we'll get that value, and then the same thing for SE for males, 4.5 divided by square root of 30. And I'll give you some, I'm going to pause this to give you some time to plug those in. Yeah, when I said that I will give you guys some time, that was more for me too. So anyway, 5.8 divided by square root of 30, 0.96 if we just round to the hundredths place. And then 4.5 is 0.82. Okay, so that is the SE for each sample. But now remember, since we have a 2 sample test, we need to find the SE difference, which is the square root of each SE squared, well, the sum of the squares. So then it will be the square root of 0.96 squared plus 0.82 squared. And that should all be under the square root. And I got 1.26 for the SE difference. All right, so now moving along, after we get the observed difference, expected, and the SE, then we use that information to find the test statistic, or the Z-score. So remember, the Z-score is the observed minus expected divided by the SE. So then we're going to take the observed difference. Since this is a 2 sample test, everything will be observed difference minus expected difference divided by SE difference. So observed difference is 0.73 minus expected is 0 divided by 1.26, the SE difference. And then, so if we're plugging that in, it should be 0.58. So the probability of observing that difference or more extreme, or sorry, this is 0.58 SEs from what we expect. Now we are going to find, with the p-value, we're going to find the probability of observing this or higher. So we are going to do norm CDF in our calculator. So with the norm CDF, remember, if it's a positive Z-score, then we are finding, if you're looking at the normal curve, oh, that's not very pretty, sorry. And this is what we expect, right? So ours is only half an SE away, so ours is right here. This is our Z-score. So we're finding this area. So most likely, looking at the curve, it's going to be a large percentage, right? Because that's a fairly big percentage of the normal curve that we are finding. So the lower bound will be the 0.58 since it's positive. Upper bound, we can just put 10 since we're using Z-score. And then the mean is 0 and the SD is 1 since we found Z-score, it's the standard normal curve. And then, see, I'm going to plug that in and let you guys plug that in. All right, so I got 0.28, which is equal to 28% about. So 28% of the time we would get that Z-score or more extreme. So therefore, we are definitely going to fail to reject the null hypothesis. Oh, this is hideous. Sorry. So if we're failing to reject the null, that means we have evidence that supports the null hypothesis. So that means we have evidence that, and if you remember, the null is, hey, we're saying there's not a difference between ACT scores, or for ACT scores between male and female at SJH. So we have evidence there is no difference between ACT scores. I'm just going to let you guys finish that. Between ACT scores with males and females. So that is how you do the 2-sample test using the ACT scores, and hopefully this will help you do your quiz. Just remember, when you look at the data in announcements in Canvas, that you're looking at the highlighted column, because that's the math ACT test. So if you have any questions, please let me know, and I'll talk to you soon.